It is part 2 of section 1.2, repetition, iteration loops. Let's begin with a recall. For each of the programming languages, there are 4 essential components to learn. Looping for repetition, conditional statements, input, output, and functions. Functions are for reusability and programming efficiency. We already treated this one in section 1.1. Here, we'll consider the 3 items and focusing on repetition. In scientific computing, one of the most frequently occurring events is repetition. Each repetition of the process is also called an iteration. It is the act of repeating a process to generate a sequence of outcomes or to get final quantities. And so that iteration must start with an initialization and perform step-by-step marching to get the result. The repetition is a very basic building block in programming. Here, the MathTalent provides a few types of loops to handle looping requirements, including while loops, for loops, and nested loops. Okay, here, while loop. While loop is formulated in this way: while, an expression, statements, and end. Once this expression is true, then the statement will be executed. Okay, let's see this example. A0 is 10, A is 10, and B is 15. And after printing out about A and B, here while loop is given in this way. If A is less than or equal to B, then the value of A is printed out. And after that, A is added by 1. Then in each iteration, A is increasing from 10 and 11, 12, or 13, so that it'll become 15. Then this loop is, that is true, because up to 15, that is true. And then after printing out A is 15, now A becomes 16, then it's not true. So that, like in this output here, this loop will print out from 10 to 15. A value becomes start from 10 and finally 15. And once it becomes 16, then that stops. Okay. How about for loop? For loop is executed for values from here, this array, this list, and for each member in this list, that is now become index, and by its index here, program statement will be executed. Here, a value can be any list of numbers. For example, you can make initial value and end value. For example, 1 colon 4, then it'll become 1 to 4, the natural numbers, integers. Or you can make here initial value and step and end value. Okay, we'll see later on some examples. Here we have now similar the environment, and A is 10 and B is 15, and here after printing out A and B, the values, and the for loop is given in this way. I is from A to B. So A is 10, B is 15, so that this A to B will be same as, okay, that is same as the list here from 10, 11, 12, 13, and 14, and 15. This is the list of these numbers. So I will be chosen from this list. So in the beginning, I will be 10, 11, 12, so that for each I, now the value is printed out. So you can see here now, I is 10 to 15, okay? Now the loop can be organized so that another loop can be inside of one loop. Over there, that is nested for loop, and we have one loop, and inside again we can put another loop. Such loop is called nested loop. For while loop, also you can make a nested while loop. And now also you can combine for loop and while loop to get a nested loop. And also you can put more than twice, and deeper loop can be made. Okay. Okay, here we have loop control statements, and frequently used one is break statement. Once the break, the loop meets break, then the loop will be broken. And here, let's see this example. We modify the code in example 1.15 to involve a break statement. Okay, now we add another variable C, 12.5. And first we print out A, B, C values, and this for this while loop. And now, okay, we added this one here from the code in example 1.15. This is extra one. So after printing variable A, now once A is larger than C, C is 12.5. So A is, for example, 13, then this break statement will be executed so that the while loop is stopped. Okay, so here the result is, now once A is 10, is not true because C is 12.5, so that it is not executed. And once A becomes 13, then it is true, and break is executed so that and stop this while loop. Okay. Okay. Now continue statement. Sometimes you want to break the loop, but sometimes you want to continue ignoring below the some position, but you want to continue. Then you may try to use continue statement. So the continue applies only to the body of the loop where it is called. And here in nested loops, continue skips remaining statements only in the body of the loop so that you can run the program continuously. Okay, here now we modify the code in example 1.16, and this is a for loop. Along with this for loop, we add a continuous statement. A0 A is 10, B is 15, the same here as in the code in example 1.16, and exactly the same also here. And then now we added this one. If mod, this modular function I2, the output is the remainder when I is divided by 2. So the output will be 0 and 1. If I is even, then the result is 1. If result is 0. And if I is odd, then result will be 1. So that for odd number I, and the output is 1, so it becomes true, and continue will be executed. So skip this portion. Okay, so only for even I here, because it's 0, it is not executed, so that it will be put into the out. The result is given exactly what we expected. Okay, so it is odd, then that will be 1, and continue is executed. So skip this one, but only for even here we can see the result. Okay. In the above, mod I2 returns the remainder when I is divided by 2, so that the result will be either 0 and 1. If it is 0, then it is false, and if 1, that will be same as true, so that it is executed. In general, mod AM returns the remainder after division of A by M, where A is called the dividend and M is the divisor. And this mod function is often called the modulo operation. Okay. Now, in MathTalent, we can define anonymous function, and which is a function that is not stored in a program file as an M file. Here, we define an anonymous function, f is, okay, at sign and x. That means that x is a variable, and this is a function body. And here we try to print out f1, so that there's no semicolon. So if you execute this program, then f1 will come out, and x, capital X, is defined from 1 to 6 integers. And now by using f-eval for function f, and for this point 1 to 6 is evaluated and saved, so that now with a semicolon there will fixed values will come out. And also here for this f, we try to get integral. If you are familiar with some calculus integration, then this is a definite integral for the function from 1 to 3, and output will be saved with q, and here there's no semicolon, so that you'll see the result. Okay, let's try to see this program. Okay, here this is Octave, and in the directory we have anonymous function. That is exactly the same program, and in the top, close all, clear all. Once you run a program again, and you may open the plots again, so that by using close all, you can close all the figures. And sometimes if you change variables, then the variables you used earlier will be remained in this running, so that by using clear all, you can eliminate the all variables in the beginning. And here format long means that in output, once it's not integer value, then along with a long format, it is printed out. Okay. Okay, we can run it, which is same as F5 from keyboard. So I'll hit F5. Okay, then it is executed. So that we go command window, that is now executed anonymous function, and F1 is -2 f of x, the 6 values, and this last one is for the definite integral of f from 1 to 3. Okay. Okay, that is exactly the same output. Now, finally, in the section, we'll consider open source alternatives to MathLab. Here, you just saw Octave. Octave is the best known alternative to MathLab. In fact, Octave and MathLab are not exactly the same. However, most of the program will run in MathLab and also in Octave without modification. And sometimes you need a little bit of modification, but you can easily understand where you have to change. So here, by using Octave, you can do the MathLab program. And in Python, in NumPy is the is the main package for scientific computing in Python. It is quite well organized, and you can deal with n-dimensional arrays and complex matrix transforms and linear algebra, Fourier transforms, and now also you can use it to call some other languages, C, C++, and Fortran. Particularly, it's quite easy to include Fortran programs. And as a matter of fact, among the computational languages, Fortran is the fastest one. And the NumPy is organized to mimic MATLAB, so that once you understand the MATLAB, then later on you can use NumPy very easily. We'll consider the Python basics in chapter 7. Okay, this is the end of the section. Thank you.